Hello again everyone, my name is Avkash and let's take a look what we are going to cover in this video. We start this video by building the face style transfer AI model by using the two separate styles. One is Buzz Lightyear face and other is Buzz Lightyear suit. Using the JoJoGAN face stylization method, we are going to build these models to apply the style on any given face, which will result for us to get the result output. The last two videos in this JoJoGAN series, we have already learned how to train your own model and apply the style to any given image. This video is going to explain you how you can export the model by saving your model checkpoints and exporting model as well as other files to any other environment where you could create an standalone application to perform the inference by using the JoJoGAN StyleGAN AI transfer models. This video is going to help you to deploy your models to Hugging Face, weights and biases using Gradio Python application or just building a very simple Python Flask or Python Fast API application. The content covered in this video are going to take three different steps. At very first step, we are going to use the Google Colab environment to first train the model and then save the model checkpoint to the disk and then export the model and other files from Google Colab environment to our local file system. In the second step, we are going to use the Google Colab environment and use our own models and other files to perform the inference. And the third step, we are going to deploy the models which we have trained at the Google Colab using JoJoGAN library. We will deploy these models at the Hugging Face by using the Python Gradio library. Before we start our exercise in this video, I just wanted to let you know that this video is the part of three-part series related to JoJoGAN. First two parts we have already completed the training and the explanation with regard to training and inference and various other details such as GAN and StyleGAN and everything else in between. This video is all about model export and deployment on various environments such as local file system and the Hugging Face. So let's get ourselves started. So in the last two videos, we have completed the JoJoGAN one-shot face stylization transfer exercise. That exercise is available here in this GitHub repo. And I have already opened this exercise at my Google Colab environment. I do have access to GPU here and this session is connected. So I will not be explaining anything. Our objective is to build two style transfer model. First, we are using the Lightyear face image and the second style is Lightyear shoot. The environment is ready. As you can see that JoJoGAN is already cloned and as you could see the folders are already ready. I'm just going to upload the style image which we need for us to use as a source image for the transfer. So here is our Lightyear face image and here is our Lightyear suit image. For the test image, we are going to use this avkashoh.jpg on which we are going to apply the style. This is our face image look like on which we are going to apply the style. First, we are building the model using the Lightyear face. So that's our source style image. This is the style which we are importing. And we are going to fine tune our StyleGAN by using the 500 iterations. As you could see that our model is trained for 500 iterations. Here is our reference image and here is our output image. So based on Buzz Lightyear face model, this is our transformation after we have applied this Buzz Lightyear style image. Now I will show you how you could save this model. So let's go a little back and as you see here at this is the point where we have trained our model. At this step, as you could see here, that we have original generator. This original generator is the generator which has all the layers combined with the StyleGAN as well as the style which we have just processed. So let's come here, look into original generator. So I will be creating one shell. Here you could see this is your original generator, and just accessing it, you could see that this original generator is actually a whole StyleGAN model. Here you could see the number of layers. This model had 17 layers. If you would want to see state dictionary, this is the state dictionary. And this state dictionary is what we are going to save as the checkpoint model. To save it, we are going to use the torch.save. So we already have imported the torch, so we could call this torch.save, and we are going to save this original generator dictionary, and then we need to give the path where we would want to save. So we want to save at content, then JoJoGAN and the model. So this is the place where we are going to save this model, and then the name will be Lightyear Phase Checkpoint. So we just call it chk.pt. That's our model. Let's save it. After that, we could validate it. And as you could see here, that this is the Lightyear Phase Checkpoint is saved here. If we would want to check what is the size of this model, you could say ls.lah, and here you could see that this is the checkpoint, which is about 127 meg. So we have saved the model. In order to export this model from this environment, I would want you to learn three things. First, need to get your checkpoint model, which we have just saved. Then style image, if you see here, that this is the Lightyear face, which we have used as a style. And once this face was aligned, we can also see that this Lightyear face aligned image is also there. So we need to export three files: Lightyear face, so this is the style image aligned, style image, and the models. So these three files we need to download from this environment. So I will be downloading these three files. And one thing you can also check that our style image source is the JPEG, but the aligned image is the PNG. So it means that it's easier for us to separate them. So Lightyear face, let me download it. Then I will be downloading this checkpoint model to my local file system. So at this point, I'm downloading from this Google Colab environment to my local file system. Similar to Lightyear face, now I have already built the style model for the Lightyear suite. So that was the image. And as you could see that here is the style reference. The model is already completed. After that, I have also saved the model as a Lightyear suite. So that is also saved. Here is the reference and here is the output. So based on our two source images, we have already built these two models, and we have also downloaded these two models to our local machine, and this is how everything look like. Here you can see that based on our two models, we have created one for Lightyear face and other one for Lightyear suite. These two models are downloaded locally. Style images are also downloaded locally. Their style images aligned is also downloaded locally. And I have also downloaded the inversion codes. Even they may not be needed for us to create the inference application. However, because the inversion codes folder has these two PT files, so I have already downloaded these two. So that's all you really needed in order to export your model. So if you would want to create your own inference application, you can use these files to perform the inference completely. So in this section, we are going to use the custom model which we have just exported in the previous exercise, and we are going to perform the inference in this Google Colab environment only with our style model which we have created plus one Disney model which I have exported from the previous environment. I already have Google Colab notebook ready. Just to make sure that you must need GPU for this exercise. So GPU is also ready. Step number 1, we are going to clone the JoJoGAN repo as well as install some of these packages and modules which are required for us to complete our exercise. JoJoGAN is available. As you could see that models folder is not there and only some styles images are there. So it's just the vanilla JoJoGAN repo has been cloned in this machine. Next, we are going to import these Python packages. Deep copy, we are using the CUDA neural network, benchmark as true. Now we are importing some of these modules which are related with JoJoGAN. So we are actually importing these modules from here. So model, E4 projection and util. So later when you are going to see that when we are calling this generator or we are calling some of these methods such as this where it shows that method is not defined, they are actually coming out from these 3 files mainly. This step takes usually some time. At this point, we are just making sure that our runtime environment is getting ready to use the styled model. We are going to create some of these folders if they are not there. So models folder will be added now and the inversion code, but that is not really needed at this point. At this point, we need to copy the checkpoint models as well as the styles image aligned file. So I have copied all the models and all the style aligned images at my Google Drive. That's why my drive is mounted here. So at the bottom of this Jupyter notebook, I already have a list here what files you really needed. So you need these data file as well as these checkpoint models and your own checkpoint models, because in our case we have light year face, light year suit. So we are going to use. So I will be running these commands, and what these commands are doing is that they are copying the file from my drive which is already mounted here in this Google Colab environment to my local environment in this Colab environment. So let me just run all of these command. This file is about 1.2 gig. Let's take some time. Rest of the files are around 100 gig, close by plus minus. So now first these are the required file. Here you could see I'm downloading the Disney model and dlib library for face detection, E4E as well as the StyleGAN. So these are the required. Next, I'm downloading my own model, light year face checkpoint, light year suit checkpoint. At this point, because checkpoint name is not really needed, so I'm renaming the light year face checkpoint to light year face and light year suit checkpoint to light year suit. So these 2 steps, just renaming the file. Next, I'm taking the light year face style aligned file and I'm copying it to the style image aligned folder. Similar for my light year suit. And finally, I'm just using my own image as a test image. After these files are copied, now we can come back here because copy process is done. It means we can validate what is in our models folder in this JoJoGAN. So you could see that these are the 2 my models, StyleGAN and E4E is required for us. dlib for face detection, and this is the pre-created model by the JoJoGAN team. In the style image aligned, bunch of files were already there because of a cloned repo. These 2 files are added by me. In the test input, these 2 files were already there, avkash-o jpeg, I have added it. So our environment is all ready. Now we can perform the inference. And just to make it really very independent, I decided not to use any other library which was not needed in this demo. That's why I just copied everything on my Google Drive and I'm using that to copy. It means if you would want to create your own Python or any other environment, you can actually use that way. We are using CUDA, so I'm setting up device as CUDA to be used. Next, we are setting up our generator, because we are using StyleGAN, which is a composition of generator and the discriminator. So our generator object is being created. We are also setting the transformation for our images. So 124 by 124 image as an output where the output will be generated. At this point, as you could see that my source image is avkash-oh. So that's what I'm using, that source image. And let's load our source image. We do not need the left side at this point, the list of files, etc. So I will close this panel. This is the image, which is my source image. Now here, as you could see, that I'm using the Lightyear suit as our model, pre-trained model, and I have made few changes. So that's all we are really trying to do. We are not downloading anything because we have already copied the model, and we are loading the model, setting up the generator. The weights are being collected from the generator for the loaded model, and then transformation is done. And at this point, transformation is complete, and now we are seeing the results here. So let me load this model, which is our pre-trained model, that's pre-trained. At this point, the style application or style processing for this given image has already been done. We just really need to see the results here. Here are the results. So this was the Lightyear suit model which we have loaded, and this was the source image, and here is our output image. If you would want to test the Disney model, I will show you really quick test. What you need to do, you just need to change this pre-trained from Lightyear suit to Disney. So I will comment this and I will use the Disney. So now we have loaded the Disney model and we have applied the Disney model to this source image. That job is completed, and I will keep this code as it is. I will just show you the Disney model here. And there you go. So this is our model and this is Disney model. So I will just make a comment here. So that's how you are going to use your custom model and complete your inference. Let's export this Jupyter notebook to GitHub repo. So here is the Jupyter notebook which we have just completed, and this Jupyter notebook has all the code to apply our custom model and the pre-built model and the files which are needed to be copied from your whatever source. In this case is the Google Drive to this particular Colab environment. All the files which we have covered in this exercise are available in this JoJoGAN folder at the DeepWorks repo. So that's all I had for you in this video. I hope you have enjoyed all the content we have shared in 3 different videos. I do appreciate for your time, and I'm looking forward to seeing you in my next video. Until then, thank you so much.